Hello everyone, I am Sangeet P. Along with my team member Pavadi P, Shabil Hani and Nasi Nazar. So we are presenting our internship titled Temperature Monitoring and Alert System using PIC microcontroller. So this project was developed as a part of embedded system internship conducted by Emertxe Information Technology. So during this internship, we learned about mm, we learned about basics of C programming. That is, C programming is a general-purpose programming language which is developed by Dennis Ritchie, and it is used to communicate with system and hardware. So it is widely used in system software as well as embedded system, and it is much portable and efficient compared to other programming languages. There are three levels. Uh, First one is high-level programming languages. So the example of high-level programming languages is Python, Java, and there are other programming languages also, which is programming language is more abstract. It hides many details. Uh, it is a front-end programming language. It is used to do front-end works like web development, software, Flutter, etc. Mm. And coming to the low-level languages, low-level programming language. Here the example for low-level programming language is assembly language. It is stay much closer to the hardware. To do coding in the register level. Mm, with the registers. So next one is middle level programming language, which is C programming. It contain both features of low level programming and high level pro programming. All. Mm. And so why this C programming used in embedded system? So as I said, the C programming also lies support the both features of high level and low level programming language. So it stays close to hardware also, and it uses less memory space compared to other programming languages, and the speed of execution is much faster, and it allows bit manipulation also, which is much essential for so these features. This C programming is used in most of the microcontrollers. So that's why C programming is used in embedded system. And we also learned and about the features of C programming. So we learned about data types. These data types, we have the data types such as int, char, float, double. Int is used to represent the whole numbers, and char is used to represent the characters. And float and doubles are used to represent decimal values or fractional values like temperature reading, etc. And next, we also learned about modifiers. There are signed, short, and long. This unsigned modifier is used in embedded system to represent positive values only, like sensor, row count, the digital counts, etc. So coming to we also learned about the operators. The operators are arithmetic operation, relational operation, logical operation, and bit-based operation. The arithmetic operations are addition, subtraction, multiplication, division, etc., which is used for scaling different types of sensor voltages, and etc. And we also learned about relation and logical operation for comparing different types of values, current temperature to the threshold. Like we used to calculate threshold value using these operators. We also learned about bitwise operator, which is used for specific setting specific bits in PIC registers. And we learn about control statements. That is for decision making. We have if, if else and switch, which is this decision maker king statements are used to trigger alert systems in our project. Like if temperature reach a particular limit or exceed a particular threshold value, turn on the buzzer. Like that, we use this control statement. And we also have loops like for loops. We use for loops, while loops, do while loops in our project. These are used to run a particular block continuously, like setting a loop. And next we also learned about arrays. So the arrays are the collections of same types of elements in continuous memory. In this temperature monitoring, the array could store last time reading to calculate the smooth average. For calculating the average, we can use the array here. And we also learned about functions. Functions is simply a block of code used to perform a specific task. For example, and syllabus we can say for for finding the area we can define a function for finding the program the code continuously. We can set this. We can define a function and we can call it again and again. So 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 by using this function, we can improve their reusability in our code. And we also study about pass by value and pass by reference in function. And we also learn about pointers, strings, and storage classes. So, so the pointers are these variables store the memory address of another variable. So it is used to access. Uh, so it is used for memory access and reference. They are used in embedded system for high-speed memory access and hardware register manipulation. Then we also character which is ending with a null character. Then, mm, then we also studied about storage classes like auto, which is used, which is a default local variable, and statics, which retain its value even after the function end. And we also study about extern, which is used to share variable across different codes. And we also study about register. Mm, And also we study about different pre-processing directly, like hashing, loop, define, if, def. And what is embedded system? Right. So the embedded system is a dedicated system that is designed for a specific function. Like you can see in embedded system gadgets like uh, washing machine, smartphone, speakers, almost everything is an embedded system. So it consists of both the hardware and embedded software, and it works in real-time environment. So next we learned about the microcontroller also. So the microcontroller is a complete system on a chip. That means it contains not only the CPU, it also contains memory, I/O port, timers, and peripherals. So this is mainly used in embedded system and automating applications. That is microcontroller, and it acts as a control unit in real-time access. So you can see a block diagram of microcontroller here. Here you can see the CPU for interrupting. That is, we can change the interrupt according to our priority. Interrupt. We can set the priority in our interrupt control, and we can see read-only memory and random access memory timers, oscillators for setting the clock. You can see bus controller. We have data bus, control bus, um, uh, and address bus. And you can see the four input output ports. And you can also see the serial communication ports, transmitter and receiver. So this is about microcontroller.
Allows us to accurately convert analog sensor values into digital form. In addition, the PIC 16F877A supports timers, interrupts, and serial communication, enabling efficient and real time control uh, and also reliable data handling. Due to these features, it is widely used in embedded system applications and is well suited for our project requirements. Next, I would like to briefly introduce Embedded C, which is the programming language used in this project. Embedded C is specifically designed for programming microcontrollers and embedded systems. It provides low level access to hardware, allowing the developer to directly control registers, ports, and peripherals of the microcontroller. This enables us to utilize the full potential of the hardware. Another advantage of embedded C is its efficient memory usage and precise timing control, which are very important in real time applications. Because of these features, embedded C is extensively used in real time and safety critical embedded systems. Now, coming to the software tools used in our project development, we used the MP Lab IDE for creating, coding, and managing the project. The XE8 compiler was used to compile the embedded C program and convert it into hex file, which can be uploaded to the PIC microcontroller. In addition to this, we used PIC SimLab to simulate the circuit and demonstrate the working of a project, which helped us in testing and validating the design before implementation. Moving on to the project introduction, I would like to highlight the importance of temperature management in electronic devices. Temperature monitoring plays a critical role in many real-time applications. Excessive heat can reduce the performance, reliability, and lifespan of electronic components. In many practical situations, manual temperature monitoring is not feasible, especially when devices
Here, the
operate
slide
continuously
shows the
or are
block
located in
diagram
inaccessible
of a
environments.
temperature monitoring
This
system.
creates
My
the
name
need
is
for an
Pranati,
automatic and
and now
reliable
we can
temperature
discuss about
monitoring
the
system.
block diagram of temperature
This
monitoring
leads us to
system.
the problem
Here,
statement
the
of a project.
potentiometer is used to simulate the temperature
High temperature
sensor
in
and
electronic
calculates
devices
an
is a
analog
serious
voltage
issue
based
that
on
must be
temperature
addressed properly.
variation.
Overheating can
The
cause
analog
permanent
signal
damage to
is
components
given
and may
as
even lead
input
to
to
system
ADC
failure.
module of
Manually checking the temperature repeatedly is
F877A
time consuming,
microcontroller.
inefficient,
The
and
ADC
prone to human
converts the
error.
analog value
Therefore,
into
we
digital
identified the
value,
need for an
which is
automated
processed
temperature
by a
monitoring
microcontroller.
and alert
The
system
processed
that can
temperature
continuously
value
observe
is displayed
temperature
on a 16 to
that
2
can
LCD.
continuously
If the temperature exceeds the predefined threshold, the microcontroller activates the LED or the buzzer to indicate an alert. Thus, the PIC microcontroller acts as the central control unit for the entire system. Now discuss about the hardware components. Here the slide explains how hardware components used in our project. The PIC16F877A microcontroller is the main processing unit of the system. The potentiometer is used to simulate the temperature sensor by providing a variable analog voltage. A 16 to 2 LCD is used to display the temperature value in real time. An LED or buzzer is used as an alert indicator when the temperature exceeds the threshold value. Resistor and the connecting wires are used for proper interfacing, and regulated power supply provides stable voltage to the circuit. Now we can discuss about the working principle of the system. Here, the potentiometer generates an analog voltage proportional to the temperature. This voltage is applied to one of the ADC channel of the PIC microcontroller. The ADC converts the analog signal into a digital value. The microcontroller processes this value and convert it into a corresponding temperature reading. The temperature value is continuously displayed on LCD. If the temperature exceeds the predefined threshold, the microcontroller activates the LED or buzzer, generating an alert. Now we can discuss about the chart of the temperature monitoring system. In this flow chart, initially the system initialized the ADC module and LCD display. Then it continuously reads the ADC value from the sensor. The ADC value is converted into a temperature reading and displayed on the LCD. The temperature is compared with the predefined threshold value. If the temperature exceeds the threshold, the alert is activated. Otherwise, the system continues monitoring in a loop. Now, I will hand over the presentation to my teammate Shabil, who will demonstrate the project practically.
Hi, my name is Shabil Hanin. I am a electronics and communication student. In this project, first of all, I present about the demonstration of our project. The project was first simulated using PIC to verify functionality. A potentiometer was used to vary the ADC input, simulating temperature changes. Based on the ADC value, the LED response and LCD display output changed accordingly. This confirmed that the system works correctly under different input conditions. And next slide about application of our project. The system can be used for industrial temperature monitoring to prevent overheating. It is useful in home safety systems such as fire or heat detections, and it can be applied in medical equipment monitoring where temperature control is critical, and it also helps in electronic device protection by monitoring and limiting excessive that. And next slide is about the advantages of our project. The system is low cost and reliable, making it suitable for practical applications. It provides real time temperature monitoring, which is crucial for safety and automation. The design is simple, easy to implement, and expandable for future upgrades like alarms or wireless monitoring. And next slide is about learning outcomes. And through this project, I gained a strong understanding of embedded systems concepts. And I got hands-on experience working with the PIC microcontrollers, including port configuration and ADC usage. I improved my embedded C programming skills, especially in sensor interfacing and display control. And I also learned how to use development tools and debugging techniques, which are essential in real world embedded projects. And the next slide is conclusion. In this project, we successfully designed and implemented a temperature monitoring system using a PAC microcontroller. The system accurately reads temperature through the ADC module and processes the data efficiently. The output was displayed clearly using LED and LCD, confirming correct operation. Overall, this project helped bridge theoretical knowledge with real-time practical implementation. This is the our output section. This software is MP Lab software. This software used for converting C language to machine language. Here we used a compiler, CV8 compiler, and this is the our C code for simulate the project. And we first of all build the project, clean and the build project, and we have this type of output like build successfully. and we once more build the project. We can see build successfully, and the MP after build a project in MP Lab, we get a .hex file and we import the file into the PixSimLab software. The PixSimLab software mainly used for simulation of the embedded systems, and here there are many tools like LCD, potentiometer like that, and unluckily we don't get the output of our project, and